Hello and welcome to this recreation of what we did in class. So in class, we started with our unit circles, which up to this point only had ordered pairs around the edges. We had all these points filled in, and all of these points are based on the idea that the XY axis goes right through the center of the circle. So every number you see is a measurement of how far to the right or left the point is from the Y axis and how far above or below it is from the x-axis. So it is actually on a grid on an xy plane. What we're going to add in today is our angle measurements, which were also on our right triangles. And then we're going to talk about a new unit called radians. So for our angles, the first thing we need to know is that the starting point when we're measuring angles is always the positive x-axis. Every angle is measured from there around the circle. So I'm already going to fill in that my angle here is 0 degrees. As we go around a circle, one full circle is 360 degrees. So that same spot, once we come back to that beginning, is also 360. It's both because it's the starting point and also where you land when you're done with one full circle. As we go around the circle, we could either use our special right triangles that we built for the unit circle, or since I'm doing this digitally, I'm going to use fractions to find all of the angle measurements. Half of 360 is 180. Another way you can figure this out is if you remember that a straight line is 180 degrees. Either way, this is 180. The next thing that we can use is our knowledge that a right angle is 90 degrees. So this is 90. And then at the bottom, we have another distance of 90 degrees, but it's measuring from 180. So this would be 270 because that is 180 plus 90. Okay, so now back to the beginning. We can do all of our halfway marks because this point right here is exactly halfway through the first quadrant. So that is 45 degrees because 45 is half of 90. And then now I know as I work my way around the circle, every time I pass a distance this big, I'm going to add 45 degrees. So adding 45 gives us 90. Adding 45 gives us 135. Adding another 45 would get you 180. And then we make it to the bottom circle. 180 plus 45 is 225. Plus another 45 would be the 270. 270 plus 45 is 315. And then 315 plus 45 would bring us back to the 360. So every time you pass that same size chunk, you're always adding 45 degrees. The last piece we can also do using fractions. Here we've got 3 equal sized wedges that make up the 90 degrees. So that means each of those wedges is 30 degrees on its own. So this is 30, plus another 30 would be 60, plus another 30 would be 90, and they're all equally spaced. So every time I go to draw one of those, it's 30 away from the last wedge of that same size. So 90 plus 30 would be 120, plus another 30, and another, and another. And each time I'm just adding 30 to the previous wedge. And we've completed our circle in degrees. So then the last thing that we added, or not the last thing, but the next thing that we added was our units in radians. So first let's talk about what a radian is. A radian is a unit for measuring angles, but it's measured in such a way that 1 radian is the distance around the circumference of the circle that 1 radius can reach. So as I go around the circle, what that means, and this is going to be harder to demonstrate on here because I can't pick up anything and move it around. In class, we demoed this with a string. So maybe if you were in class, you remember that. What we did was we took a measurement of how long the radius of the circle is. And then instead of it being a straight line, we actually wrapped it around the edge of the circle, which this is going to be hard for me to do freehand. We wrapped it around the edge, and it happened to run out of string right around here. right before 60 degrees. That is exactly 1 radian, 1 whole unit radian. And it's a weird spot. So we're actually not going to be counting radians in terms of whole numbers like we do for degrees, 30, 60. This time we can't use 1, 2, 3 because even when you make it all the way around the circle, you don't make it back to a whole number of radians. In fact, here's some evidence for that. We should be familiar with the circumference formula from geometry. Circumference equals 2 pi r. Well, what does r stand for? R is the radius. That means that if we turn this back into words, the circumference is equals 2 pi radiuses. 2 pi times the radius. So that means once you make it around the entire circle, you'll have this really weird decimal, this infinite decimal, 2 pi radians. Exactly. But that's a weird decimal, so we're not going to round because you could write an infinite decimal or round it and it's not accurate anymore. Instead, we're actually going to use exactly 2 pi to represent the total distance around in the number of radiuses that you can travel around. And that's the unit of radians, is how many radiuses have you gone. So when you've started, you actually haven't traveled any radiuses. That's 0 radians. And by the time you've gone all the way around the edge of the circle, you would have picked up and moved your radius 6.28-ish, or 2 pi exactly, radians. And the reason I said 6.28 is 2 times pi, which is approximately 3.14, would give us 6.28, but that's a rounding, that's not exact. So it's approximately 6.25 radiuses when you get to the end. Just like we did with the degrees, we're going to just use fractions and cut things in half and write our radians that way. So if 1 full circle is 2 pi, half of a circle would be 1 pi, because half of 2 is 1. So half the circle is 1 pi radians. Cut that in half. Halfway between 0 and pi would be half of pi. Cut that in half again, and halfway between 0 and pi over 2 would be pi over 4, because half of a half is a fourth. And then just like I did for all the 45-degree 45-degree radians, 45-degree wedges, every time you travel that distance, you're going to add a pi over 4. So I'm going to kind of like let the pi just be automatic, and I'm going to focus my attention on the fraction. At each place where you have a wedge, it's going to be 1/4. And you just add how many fourths you have. So this is 1/4. 2/4, but 2 over 4 is 1/2, so that matches what we already have. Then once we have 3 wedges, that's 3/4. The next wedge would be 4/4, but 4 over 4 is 1, so that matches what we already have. Then we go again, 5/4. You can see the numerator is the only thing that's actually increasing because it's counting how many fourths. The next wedge of that size would be 6/4. But 6 over 4 reduces to 3 over 2. So I'm going to write 3 over 2. 3 over 2 pi. All right, the next wedge, that was 6/4. This one is 7/4. And then our last one would be 8/4, but 8 over 4 is 2, and we already have it down. So the last thing we need to do is figure out what those smaller wedges are. And for that, I'm going to draw on the wedges first, actually. So I'm just going to highlight those same wedges we had for the 30-degree marks. Apologies if my calculator comes up. You can see my pen went a little crazy there and clicked on the calculator. Okay, back to the wedges. There's 1, 2, 3, 4, 5, 6. So the reason I counted was because if you have 6 equal pieces per pi, then each one is 1/6 of a pi, because there's 6 of them, so pi over 6. And then I'm going to do the exact same thing where we just count up how many sixths we have. So this is 1. This one would be 2. 2 over 6 is 1/3. And then this would be 3, but we already have that labeled. 4 out of 6, reduces to 2 out of 3. 5 out of 6. 6 out of 6 is 1. Then we go on the other side, marking all those 30-degree marks. This would be 7/6. And then we have 8/6, which reduces to 4/3. 9/6. And if you ever lose track, you can go back and count how many wedges. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9/6. 10/6. And then 11/6. Those are exactly the number of radians that we've traveled. Instead of writing it as a decimal, we're writing the exact number in terms of pi. Okay, the last piece that we added to our circle was our tangent values, because one of the things that we need to know from the very first day that we built our unit circle was that each ordered pair, each point on your circle, has a cosine value for its x and a sine value for its y. So the last thing that we have not labeled yet is the tangent. And for that, we're going to use one of our identities that we've already been using. Tangent is equal to sine over cosine, which on our circle would be the y coordinate over the x coordinate. So we're just going to do a couple of these, and then I'll show you how it transfers to different parts of the circle. So let's do like tangent at 30 degrees first. That would be y over x, 1/2, divided by square root of 3 over 2, which I like to write horizontally if I'm doing fractions here, dividing fractions. And you get 1/2 times 2 over square root of 3. Keep, change, flip. Cancel. And then we could stop here, but I know that most of the time whenever you Google unit circles, or even on like the quizzes online, for Canvas, you're going to see that that number doesn't ever appear. It's usually the rationalized version of that number, and rationalized means that we're getting rid of the square root on the bottom. So to do that, I'm going to multiply top and bottom by the same square root that's on the bottom. And that's because when you multiply these two together, it's the same thing as squaring the square root, which means it goes away, and we've gotten rid of the square root. So the tangent at 30 reduces down to square root of 3 over 3. And I like to write that up here as just like an extra piece of information in a different color, and then maybe color code somewhere on your paper that that's the tangent. For the next point, it's actually even easier. Tangent is y over x. Well, in this case, our y and our x match. And anytime you divide something by itself, you're going to get 1. So that means the tangent here is 1. And then our last point on that first quadrant is tangent at 60, the y over the x. This one's a lot easier than the first one, I promise. And then keep, change, flip. It's just square root of 3 over 1, which is square root of 3. Now, one of the tips that I gave was that you can find the tangent at any other point on the circle by just looking at points that have the exact same x and y values. Anytime you divide the exact same two numbers, you're going to get the same exact answer. So on these 4 points, the x is root 3 over 2 and the y is 1/2. So every single time you divide those, it's going to get the same exact tangent. The only difference is in the second and fourth quadrant, you've got one value that's negative. That's going to result in a negative tangent. So I'm going to go ahead and fill in all my tangents because we're talking about it. This tangent over here is going to be a negative square root of 3 over 3, but it's the same exact number as what we got for the 30 degrees. Over here, because we're dividing a negative by a negative, it will be positive. So this one would be the same as 30 degrees, square root of 3 over 3. And then over here where we had that last point that also had the same numbers, this one also has one negative number. So it'll be a negative tangent. Here's my next tip. Instead of thinking even that far, here's the shortest shortcut I know. When you look at the tangents across from each other, directly across the circle, they're the exact same. That's always going to be true. So that means now I can drag the 1 across the circle and drag the square root of 3 across the circle. And then using both logics, we will now know that this number up here is -1 because it's the same values as 45 degrees, and then it matches across the circle. And then finally, this one is a square root of 3, and it matches across, negative square root of 3, and then it matches across the circle. I'm going to go ahead and add this in for anybody who's watching the video. We didn't talk about this in class yet, but it will come up eventually. And that is, what is the tangent at these other points that I've avoided so far, the axes? You do the exact same thing. Tangent is y over x. So if we start here, 0 over 1. 0 divided by anything is 0. So the same thing is going to happen over here. And then the last one is the weirdest one, and this is what we'll end with. 1 over 0. You can't divide anything by 0. So this one is undefined tangent. This one is an undefined tangent. Okay, at this point, if you are only here to see how to fill in your unit circle, then you can tune out. The last thing that we're going to do is just practice a few questions that we did in class so that you can see how we use this before the next lesson. So for this, I actually have the quizzes that we used in class. Well, I thought I did. And I'm going to pull that onto the screen, and we're just going to practice that quizzes for a few questions. Okay, here we go. And I'll show you my thinking. I think once you understand it, it'll be much easier to do it for any question. Okay, so this one is asking us to evaluate sine at pi over 6. What that means is I need to go to the angle pi over 6 and look for the y coordinate because sine is the y. So I find pi over 6 right here. Whoops, pen. Pi over 6, and then the sine is the y coordinate. So my answer is 1/2. Can we mute? Uh-oh. Okay, now we have tangent at negative pi over 2. So negative numbers just means you're going backwards around the circle. So pi over 2 is a quarter of a circle forward. Negative is going to go backwards. And the tangent there is undefined. All right. Okay, so then we did some where you had to solve for the angle. These are actually thinking backwards. This one's even more challenging because it is a cosecant. So we have to use our reciprocal identities to help us with this one. Cosecant equals -2. Well, cosecant is the reciprocal of sine. And then that means that you are looking for any angles where the sine is -1/2. So I just go to my circle and look for where the y values are -1/2. And those angles would be my answers. Oh, the angles are in degrees for this one. So let me look at the degrees. 210, 330. All right, tangent at 5 pi over 3. So we're back to normal angles. Let's look for the angle at 5 pi over 3. That would be right here. And it said tangent, which is -√3. So each time you're looking for the angle first, and then you identify which part of that point are you actually interested in for that question. And then let's just end with this one. So cosecant at 4 pi over 3, again, cosecant is 1 over sine, but this time they're not giving us the answer. They're asking us to find the answer. So I'm just going to change the wording to sine instead of cosecant. So it's sine at 4 pi over 3, and then we'll turn it back into cosecant. So let's identify where 4 pi over 3 is down here. Sine is -√3 over 2, but that's not my answer because it was asking for cosecant. So cosecant is the reciprocal. You just flip the fraction. That should be my answer. There we go. All right, that's going to wrap up this video. If you are interested in playing the quizzes game, you can head towards Canvas and click on the 4.2 notes. The quizzes is actually in the notes, as well as unit circle copies are also found there.